So in Unit 6, Lesson 2, we're going to be solving equations by using balancing strategies. We are going to extend it to Step 3, different types of Step 3 equations, Step 4 and Step 5. So I started my class with just trying to have them solve 5a plus 7 is equal to 2a plus 1, and just to use any strategy or method that they knew how to do. And then we went on and I was showing them how you would do this mathematically. So remember, when solving equations, the goal is to get the variable all by itself. So when we have variables on two sides or both sides of the equation, just like we zero out unit tiles, we can zero out the variable tiles as well. So I'm going to show you a method here. So here we have a class example. We're going to solve for it both symbolically and pictorially. So I have a 3x here, so I have my 3 variable tiles, and it is equal to 2 variable tiles plus 8 unit tiles. Again, yellow in our textbooks are positive and red are negative. So the whole idea is to get one of these by itself on one side of the equation. So what I'm going to do is I'm going to bring these two over to the side. So I'm going to collect all my like terms, but since they're on opposite sides, I have to actually zero out. So here, since I have 2 yellows, in order to zero out, I need 2 reds. Whatever I do to one side, whatever I add to one side, I have to add to the other side. So here, since I had to add 2 reds, I actually zero this out. Well, what does that mean symbolically? Is here, if I have 8 plus 2x, which was my original, if I add 2 reds, I'm actually subtracting 2x to zero those out. Whatever I do to one side, I have to do to the other. Then I get, since this zeroed out, I get one of my x's is equal to 8. And since I have one variable tile is equal to unit tiles, I have my solution. My verification, once I know that my x is equal to 8, wherever I see an x, I replace it by 8. So here, x is equal to 8. I get 3 times 8 is 24. Here, I have x is equal to 8, so I have 8 plus 2 times 8. I have to do my order of operations, so I do the 2 times the 8 first to give me 16, and I get 24 is equal to 24. I know my solution is correct. So here what we're going to do is we're going to solve and verify. So it doesn't matter what side of the equation, my variable tiles are on. So in this case, since all my unit tiles are on the left-hand side, I'm going to take my variable tiles over to the right-hand side of my equation. I do that by zeroing out these 3 red algebra tiles, or those 3 red variable tiles, and I do that by adding 3 yellow tiles. Whatever I do to one side, I have to do to the other. So now I have my 16 unit tiles on one side. I've zeroed those ones out, and I have 8 yellow tiles. 5 plus 3 is 8, and then this now becomes a step 1 equation where I divide both sides by 8 to get x is equal to 2. When I verify, I have my left-hand side equal to the right-hand side. I have 16 minus 3x on my left-hand side of the equation, and I have 5x on the right. I know my x is equal to 2, so wherever I see an x, I replace it with 2. I have to simplify both sides of the equation now. So I have 16 minus 6 is equal to 10. And on the right-hand side, I have 5 times 2 is equal to 10. And I know my answer is correct. Okay, so let's just try a few more examples here. Since I know that my unit tiles, here are my unit tiles, are on the right-hand side of my equation, I'm going to take my variable tiles to the left-hand side. I'm going to do that by zeroing them out. I have 2 red, I need to add 2 yellow. Whatever I do to one side, I do to the other. So those 2 zero out to give you 9. Those 9 unit tiles. Here I have 3W, because I collect those like terms, and now it becomes a step 1 equation. One more step to get to the solution. W is equal to 3. I'm not going to verify this one because I just did it on the other example. On this example, I already have some on the right-hand side that I have to simplify. On the right-hand side, I have 2 yellow variable tiles and I have 3 more. So you should simplify first. Let's just say I have 5 variable tiles there. Okay. So since my unit tiles are on the right-hand side, I'm going to take my variable tiles over to the left. I do that because it just is less work for me. And the least amount of work that I do, the less chance I have to make mistakes. So now I have my 3 red tiles, unit tiles here, and I have 5 minus 8, which is negative 3x. And I divide by negative 3, and I have x is equal to positive 1. Be really careful with those negatives. Okay, so now we have a different type of equation where we have variables on both sides and constant terms on both sides. So, same thing. Our goal is to get our variable tiles on one side of the equation and our unit tiles on the other. So now I'm going to have to zero out twice. So it doesn't matter which side the variable tiles are on. For some odd reason, I always like my variable tiles on the left unless it's pretty clear to put them on the right. So I'm just going to take my variable tiles to the left. So if I want all my variable tiles on the left-hand side, I have to zero out this negative 3x. I do that by adding the positive 3x. And whatever I do to one side, I must do to the other. These 2 zero out. It's like I have 3 red and 3 yellow. They zero out. I have now 7x plus 7 is equal to 21. Now, we just solved these types of equations in lesson 1. That's a step 2 equation. Now we need 2 more steps to get to the answer. Let's bring our constant terms, or those unit tiles, off to the right-hand side. We can zero those out. We get 14. And now this becomes a step 1 equation. 1 more step to get to the answer. Divide by 7, divide by 7. And you get x is equal to 2. Okay, in our verification, since this is something a little different, I'll show you how to do it. Like I said, I'm only going to verify a few of them just to show you guys how to do it. On your quiz, please only verify the ones, unless you want to, the ones where it specifically states to verify. Here, everywhere I see an x, I'm going to replace it with 2. And then I do my order of operations. I have 8 plus 7 to give me 15 here. I have 21 minus 6 to give me 15 here. And I know my solution is correct. Okay, so again, I'm going to bring my variable tiles over to the right-hand side and my unit tiles over to the left-hand side. Did I say that right? Sorry. I'm going to bring my variable tiles over to the left-hand side and my unit tiles to the right. My apologies. I'm just going to, just so I don't have to rewrite everything, I'm just going to do the first step up here. Okay, I'm going to bring my unit or my variable tiles to the left-hand side just by zeroing these out. And I have 13y plus 53 is equal to 14. Now this becomes a step 2 equation. So now I'm going to subtract 53. I have 13y is equal to negative 39. Now this is a step 1 because it takes me one more step to get to the answer by dividing by 13. Y is equal to negative 3. Okay, I'm not going to verify this one. Same thing, why don't you guys, let me see what's coming up. Okay, I'll do one more for you and then I'll let you try that other one. Did I just do this one? I did. So that's just a duplicate. That's what I thought. Okay, I want you guys to try this one. So pause the video and try it and then come back and see if you got the right answer. Okay, welcome back. So here I'm going to bring my variable tiles to the left side. Okay. I zero that out. I have 6x plus 2 is equal to 8. And now I've just taken the step 3 equation and put it into a step 2. And we've done lots of these examples. If you've done all of the workbook, and if you've done your assigned work, these are very, very simple. Should be now anyways. And now we get x is equal to 1. So hopefully you got x is equal to 1. If not, you should come visit me during Excel block. Whoa. Okay, so here's a different type. This is now we're getting to a step 4 equation where we'd have to do 4 steps to get to the answer. As you can see, we will need to distribute this out. Once we distribute this out, it becomes exactly like the question we just were working on. So 5x minus 5. Okay. So once we distribute this out, it now becomes like the step 3 equations that we were just working on. So I'm going to take my variables left, and I'm going to get negative 2x plus 3 is equal to negative 5. I'm going to get minus 3, minus 3. Those zero out. Don't forget your negatives. And then you're going to divide by negative 2. And you get positive 4. So just really watch your negatives on these. I'm going to verify this one. Left-hand side, right-hand side. 3, x plus 1. 5, x minus 1. Everywhere you see an x, you replace it by 4 in this equation, because we're saying that the variable is equal to 4. You do your order of operations, so brackets come first. You get 3 times 5 here, which is 15, and here you get 5 times 3, which is equal to 15. So I know my answer of 4 is correct because my left-hand side equals the right-hand side. Okay, so why don't you give this one a try? So press pause and give this equation a try, and then come back and we'll be done for the first video. Okay, welcome back. So we need to distribute that out first. That's our first step. So we have negative 2x plus 4. Please be careful with your negatives. A negative times a negative is a positive. And then we have 3 times negative 2x, negative 6x minus 3. We now have just taken a very would look like a very complicated equation, and we've just broken it down now by opening up the brackets using distributive property. Now we are going to bring our variable tiles over to the left-hand side, and I get 4x plus 4 is equal to negative 3. If our variable tiles go left, our unit tiles must go right. Those zero out. We get 4x is equal to negative 7. I'm just going to make sure I have everything correct here. Negative 2x plus 4, good. Negative 6x minus 3, perfect. 0, 0, okay, good. And we are going to divide by 4. So in this case, we just have a fraction. And if you want to convert it to a decimal, please feel free, or just leave it in improper form. So I'm going to stop right here, and I'm going to I'm going to create a new video dealing with those fractional exponent or fractional equations.